Okay, so now you have a 1 in 3 and a 1 in 6 angle. Now, to make these, you draw a straight line, of course, and then you measure from a point. You put a little dot on your drawing there, and then measure with your scale up to where it measures 1 inch. Say it's right there. Okay? Now you put a point there and a point there, and then draw a line down to this point, draw a line down to that point. So it's 1 inch here by 6 inches this way. And then you make the blue cone, the 1 in 3, the same way. Straight line, measure up 3 inches, 1 inch across, and that's going to make this cone a little bit sharper, just a little bit now. Okay, now we've determined that the 1/7 of the bore is 392 or 400, which is close to a scale size, so just for sake of argument, you use the scale. You draw a line right on the center line of your 1 in 6 angle. You start with this first. And you draw a center line there, or a straight line across perpendicular to your center line. And then you measure, so it's equally on each side, 400 thousandths, so it'd be 200 on each side or 400 across. Okay, you scribe a line there or mark a line there. You do the same thing on the 1 in 3 angle. Of course, it's going to be closer to the point. Okay. Now that you've done that, you set, or you take your paper cone after you've got this drawn. Well, you don't even have to have this. You just have to have the stack, and you place it in the stack until it hits. And of course, the stack is whatever its diameter here is. Say 3 inches. Mine is about 3 inches. And the inside, of course, is so smaller. It's got a wall thickness. But here's the secret. Here's the secret. If you were to make a scale wall thickness there, because this cone has to be higher up, because our bore is in scale, that means that this cone is going to be out further out, and the actual top of it is going to be up here someplace. So what you have to do is, although we make a scale outside portion, you make a non-scale bore in it, or the vortex inside is non-scale. So I like to make mine so it's designed so it hits about a 1/2 inch to 3/8 of an inch to a 1/2 inch, just above the bottom, just below the bottom of the stack. And then what I do, and I'll draw this a little bit bigger up here. Like say this is the stack, the edge of the stack, and then the scale part would be there. What I do is and my 1/2 inch is here. What I do is I flare this out on the casting like this, so it doesn't look so thick up here, because it's definitely going to be smaller than scale. So now the blast is going to actually hit a little bit lower, but then again you're going to get the scale appearance on the outside. So now you bring your cone into position at that point, and where it drops down and the 400 thousandths comes, that's where your blast nozzle has to start, the top of it. So now you have that. Then you set this 1 in 3 cone in, and where it goes up, it more than likely somewheres try to get it above or near the center line of the boiler, because that's about where the flues are usually, right in this area. Right in this area. So you don't want it down too low, because then it's a little too close. You want it up a little bit so you have a free flowing. And it usually comes out that way. So you set the 1 in 3 angle, so now that determines exactly at the bottom where the petticoat, say this is the petticoat flare, and the radius of the diameter stack starts right there. That's where you want that 1 in 3 cone to hit, right there. This is nothing more than an area to draw in and deflect and direct, to direct the smoke and the cinders and whatever. The steam's coming out of here, so it's not directing any steam, it's only directing smoke. Alright, so now when you do that, and you have this now taper inside the stack here. That's important. It's not as critical as it would be in an injector, but it acts like an injector cone. The green area that I have drawn in green here becomes the vacuum and the exhaust there. It gives vacuum in this area. And I show the exhaust here in green. I probably, anyway, it comes out here now, up in here, and then it goes up out. And there's a little bit of a wall in the center of the blast nozzle, and that kind of stops the steam from bouncing around there, directs it a little bit more straight up the blast nozzle. And this is a little stand. I make them out of brass usually, and then the ring. If we were to set this without reducing the diameter of the stack up here for scale purposes, this blast nozzle would be down here someplace on top of the lead truck, because the angle would then move down in order to get it to wipe or swipe the sides of the stack. So that's why I reduced the diameter here at the top, so that I can get a decent sized blast nozzle or something somewhere similar up there on the top. It could even be 1 inch high. Mine happens to be about 2 inches high, and that seems to work fine. So you have to kind of balance all of these things out, and that's why it's a really good idea to lay it out on paper. Now, I mentioned my friend John Lukasavich with his K4, and he had a 1 inch blast nozzle. Well, that was probably hitting up inside here someplace and not giving any vacuum. So as soon as he reduced it down, and he did do that, I think he made it a little too small because he followed what I did, and his cylinders are bigger. He made a 7/16, I believe, hole, and he got a lot of back pressure. So hopefully he's opened it up. I said, well, maybe you should open it to about 1/2 inch. So he opens it up to about 1/2 inch. I believe he'll be okay. I could probably stand a little bit bigger hole. Now that all depends on how much of a load that you're pulling. Now on a normal load, we pull passenger cars at about 10 passengers, and we have at the Pennsylvania Live Steamers about a 1.5% grade, a pretty good distance, about 1,500 feet climb, about a 1.5% grade. And the engine performs fairly well, in fact very well, and we don't have any problem building steam. We have actually too much steam, so we have to kind of subdue the fire a little bit to save and conserve. But if everything's set correctly, you hardly ever get any cinders. This all also depends on the quality of the coal you have. I mean, if you got dirt coal, if you're burning dirt, well, you're going to get a lot of cinders in your face. But the coal that we happen to have currently is pretty good stuff, and we get it from western Pennsylvania area and Altoona area, and it works pretty good. Nice size, about 3/8 to 1/2 inch nuggets, and it's very clean, I think. They say it's Pocahontas, but Pocahontas coal has to come from Pocahontas County, West Virginia. It can't come from Pennsylvania, but then it's Pennsylvania. Of course, that also has a lot to do with the sound. Not only the square ports, but the way the blast comes out of here and the size of the blast nozzle. Now, Mr. Keisel, who was a chief mechanical engineer for the Pennsy, got his name tagged to a lot of innovative inventions that the Pennsy had. However, he probably had zero to do with it other than signing the approval sheets. But some other designer came up with the quote-unquote Keisel. The most important thing of all is to have these ratios correct. If you do this, your engine will run like a dream. And I got this principle from Martin Evans, the English chap, the Model Steam Locomotive book. Joe Nelson's book, I don't know if it's in there, So You Want to Build a Steam Engine. I always felt that title was a little like, aha, you want to build a steam engine, go ahead and try. But I knew Joe Nelson, and it's a great book, and I use it all the time. I still use the blast nozzle, and give it a try. If you're having problems, give it a try, and see what it develops for you.